arrays in C and Labview. Those are two different programming languages, and there are some major differences in the way arrays are implemented. To start with just a summary of all the differences. In C, every array has a static size, and in Labview all arrays have a dynamic size. In C, a string and a byte array are in fact exactly the same. Of course you have the string object, but that's something else, that's C++. And in C, Labview, there's a complete difference between a string and an array. In C, you are going to use index and pointers to address the array. And in Labview you don't have pointers, you only have the index. Then in C you need to allocate memory yourself. So if you are going to use an array, you have to allocate some memory. And if you don't use the array anymore, you have to clear the memory. In Labview you build an array as you go. So if you need a longer array, Labview will allocate more memory for you. And if you don't need the memory anymore, Labview will deallocate the memory. And the biggest difference in Labview and C is if you make a bad implementation. So if you write poor code, you can run into serious dangerous problems in C. So you can also open some backdoors. And in Labview, the worst thing that can happen is that you get a low performance. And if you really make a mess, you can run out of memory, but then you will have quite a nice crash. It's not completely as dangerous as in C. I will talk about the items on the arrays for a number of items. This is the agenda which I will follow. First of all, I will talk a little bit about static arrays as you make them in C. So I will do something in Labview as if it is C. But of course that's not the optimum way. In fact you want to use dynamic arrays, but that's something else which I will show you. And then I will show you some of the better things in Labview. If you are going to use arrays, they really function very well with loops such as for loops and while loops. And then I will also discuss some basic functions which you are provided with in Labview, such as determining the length, search, sort, minimum, maximum, and other things you can do. And then in the end I will come back to the danger in C and the poor performance in Labview. So let's start with some basic code. First of all, I've made a part of C again with some basic functionality. This is an initialization of an array of 10 elements. Here I have something done with a loop, and here I have made another initialization which is filled with a constant, and here I have another constant which is filled with characters instead of numbers. The most common way to start, of course, in C is to start with specifying a fixed array which is not filled. I can do the same in Labview by going to the array palette. I can select it so it's fixed on the panel, and here I can say okay, initialize array. Here I can define the content of the array. So now I can say a numeric constant, and I can select every representation I like. So if it's an integer, I say okay, integer 32-bit, that's good enough for me. And here I can determine the dimension size, and I can say size is 10. So now I create an array which is 10 elements long, and I can also create an indicator, and then I can show you the front panel, and now you will see that the front panel contains an array which is grayed out. That means it's empty, and if I make the screen a little bit bigger, you will see it becomes more than 10 items. If I now run this application once, you will see I have an initialized array of in total 10 elements. So this is what you would do in C. You would start with some kind of the definition that you say, okay, this is my array size, and then you will allocate in this way the memory, and you will start playing with it. For example, you can make a loop where you are going to fill every element in the array with a number. I can, I'll come back to that when I will talk about loops. So, another way of defining an array is to define an array constant. I just initialized an array, which is a default array, but it's typically it's not really a useful situation to do something like this in Labview. Another way I can make an initialized array is by placing the array constant element, and I can just drag in some elements. I can now extend the number of elements, and I can say, okay, I'm going to fill in constants, just like I have in this line. So now I have an array which is defined by the length by the elements, and I can let's see, take that away. I can now say, okay, I can create a filled constant array. And now again, you will see I copied it. Something Labview automatically does for you. If you are going to create a constant, it will, or an indicator, and it's connected to a constant, it will automatically copy the data from that. What I can do is I can say, okay, data reinitialize values to default. It's just outside the screen for you. Edit data operations. I wanted to do it for the panel. It's also possible. This is something I didn't expect to happen, but what I did, I've made a field of, I created the indicator in this way. I can repeat it. I said, okay, create indicator, and I created the indicator from the constant. So if I create the indicator for from the constant, it will automatically fill the indicator with the default values, which are the same as the constant. The other way around, if I would have an indicator which is filled with a constant value, with a default value, I can say, okay, create constant, and then it will also fill the array with the constants. This is something which is very useful while you are debugging or making some kind of test VI. If you are running your application and at a certain moment there is the data is filled with correct settings, what you can then do is easily create a constant value, but in this case it's not really what we want, because we want to have something that I will show you, that it will fill the array for you. Yeah. So I will come back to that later, but now I have copied an empty array, which is now default value is empty, and if I now run it, you will see it's filled with a constant value, just like you would expect from the C code over here. Now another thing what you want to have is an array which is filled with characters. Now I can do it to make a little bit more clear what happened just back then, a few minutes ago. What I will do, I will create an array constant on the front panel. So in this case I have an array constant, the same as the array constant I made on the panel, but this time I will make it on the front panel. Or this is in the diagram, this is in the front panel. Now I want to put in strings, and I will just drag so that I will see a number of elements, and I will fill in these values C, O, D, E, and here of course I have the /0, which is not really a normal function in Labview, but I can still change the strings to a hex display, and then I can fill in non-normal characters. And if I represent the information with slashes, you will see that's filled with 0, with a /0 value, and if I have a normal display you will not see anything, and in hex again you will see zeros. So now I made this constant as a filled array, and what I can do is I can say data operations make current value default, and this is what was happening a few minutes ago, more or less by accident. Yeah, it's not really accident, but it's some common, let's say muscle memory, you know that it's happening. So I can now say make this value default, and now it will automatically be filled with this. Here I have the array on my diagram again, and again I can say create constant, and if I say create constant, it will fill the array with the default value of the indicator. Okay, so this is some ways of making fixed size, it's not really fixed size arrays, but this is how you can make an array which has some predefined values. As I already explained, you don't really have fixed sized arrays. Every array is a dynamic array, but in this way you can create an array which is predefined and has some fixed, some length, but still this array I can just add elements and do anything with it. So going back to the agenda, I just show you how to create an array, and I will now show you some stuff how to index arrays. So now we're back with our front panel, and let's do some stuff to index some array. I didn't put in some code here, but you can imagine that I can now do something like printf, or let's say k is our array and then element 3. This is something that should of course result in a value 4, so then k will be 4. Here again, going back to the example I made, let's say this one is R, so that this array is this array, and now I want to select the third element. I will use the index array function like this, and I will just connect the array, and I will create a constant here 4. So what I've done, and then I can create an indicator which I will call k, and I can remove all of these, but I can just let them be here as well. And now I've made here the function k is R4. So this, what you see here, is the same as this. This is my value k, which is my, of course it's this wire, which I will call k, is my variable k. This is my array, which is called R, and this is the fourth element. If I will now run this code, sorry, I was going to plan on doing 3 for the example, and now if I run it, I get a different value because I by accident made the constant array starting at 0 instead of 1 in the example. But that's a good way to show you something else. Of course, editing in text is really simple. You can just say, well, so this is how you can add an element. Of course, here you cannot add an element that's easy. The same if you want to delete this element, you can just select it and press delete. Here I can do the same with delete element and insert element before. Of course, doing it this way is not as flexible as it is when you are doing it in a text language, but on the other hand, this is something you normally really never ever use. Only for some very short arrays, and then it's quite convenient as a matter of fact. If you would have to make something with a very large constant array, you will do what I just did in the beginning by accident. You will make just some kind of code which will fill an indicator, and then you will create a constant from that indicator, and the constant will be filled with all the values. Now let's again run this application, and now you will see, okay, probe 1 is value 4. So this is how you index an element in the array. What if I would be doing something like this? If I also want to have J, then in C you will have to reprogram the entire line. While in Labview you can just stretch the index element. So if I want to have the next element as well, I can say, okay, create indicator, and I will call this J, and here I can run it, and I get 4 and 5. So now here, and this is where Labview is a little bit faster in writing your code. This is of course faster to do than typing it again, but on the other hand, some other stuff are again easier in C. Okay, let's manipulate some stuff in an array. Well, let's do something different. Let's say R2 is 12 and R0 is 1. How do you do the same in Labview? Again, I will first clear up a little bit. I will get rid of this stuff. And now I will use the replace array subset. That's the easiest one. So now I can start to change constant of index number 2, and I can change this one to 12. And again I can stretch the build of the replace function, and I can say, okay, now I want to jump not to the next index, but I want to jump to index 0, and I can make index 0 a 1, which in fact it already was, but it doesn't really matter. And now I can wire it to this display again, and if I now run this VI, you will see that array element 0 is still 1, and array element number 2 has become 12. Again, I will paste this in here. So what you saw me doing is using the array palette, which you can also pop up in this way. You have a lot of array functions, and I can just insert an element into the array. So that covers more or less everything about static arrays, as you can do in C. Sorry for the PowerPoint, I cannot really make it in a small or running in the video. Hope I don't click it too much. But of course, as I already explained, in C you have static sized arrays, in Labview everything is dynamic. So let's go back to create a dynamic array. Dynamic arrays in C, sorry, they are not really existing, so that's easy. If you want to make a dynamic sized array in C, you will have to call some library function, or you have to make some kind of linked list in your own implementation. There is not really a predefined way. In Labview, all arrays are, how do you say, dynamic sized. You have dynamic size, yeah. So probably if you are looking at some other examples of how to program in Labview, you will, if they are working with arrays, they will first start typically with a loop, and then if you start looking yourself, you will find the build array element, and then you will get this thing, and you will probably be thinking, okay, what is this and how does it work? And you get a little bit messed up. Well, this is quite easy. I can again stretch this out, and instead of making the constant array as I made before, I can just say, okay, let's connect a 1, and now I have a normal constant. I can add another constant, and I can add another constant. And now I have 3 types of the same constant, and these 3 constants are now added together in an array. So now I can say, okay, this is my array, and again here I can show you the array. I will throw away, I'll keep this one for reference. So what you will see, this is an array which is made as, I explained it as if it was a constant array, but in fact it's an array which is pre-filled with the same value. And in this case I make an array of 3 elements which I have connected. And here you get the array 1, 2, 3 with 3 elements. Now again I can play with the array, but because instead of just adding an array of constants to an array, I can start playing with the array. I can connect arrays to each other and constants to an array. So the build array does not only add elements, but it can also add an array to another array, and it can also add constants to that array. If I now again create an indicator, I get a really big array. And probably the screen won't be big enough, but let's see if it's working. Oh, sorry, this was in front of it. And what you see now is I have my array, which is now a combination of this array, the initialized array, and the element 3. And you can see indeed 1, 2, 3, 10 zeros and a 3. Let's make this one 4 elements long, and let's make that one 12. I will run it again, and now you will see that the array, this part is grayed out again, and this part is filled. So what you see is that each time I use the build array, I am adding elements to the array. So that means that the size of the array changes at the moment I do, if I add something or if I delete something. In the background, if you are using C, if you allocate an array, it will allocate all the memory it needs for that array. Within Labview, it will allocate enough memory for the array to fit in, and it will do it in a more or less smart way, and it will keep the size of the array in runtime. So that was how to create an array, and now we'll have a look at how to split and merge arrays. Of course, I just did the merge, but now let's have a look at the split function. Going back to my diagram, here I have my really big array, which is just filled with only 10 numbers, so it's not really that big. But again, I can use the array palette to do all kinds of stuff. For example, I can take an array subset. I can take an index again, so I can say, okay, at which location do I want to split the array? And let's say I want to do it at the second element. And I can say how long do you want to have the array split. And let's say I want to have 4 elements. So in this case, I can create an indicator again, and now I will take a part of this array starting at element 2 for 4 elements. So if I now run it, this is element 0, element 1, element 2, which is the first one there, and then I have 4 elements in total. That's a way to take a part of an array. There are also other ways. I can, for example, split an array into 2 arrays. So in this case, I can again create a constant to say, okay, let's split the array at element number 3. And I can say, okay, let's only reuse the first part. I can also add the second part. And now you will see I will get 2 arrays. So now this array is broken into an array 1, 2, 3 and the array 12, 12, 12, 3. So this way I can take an array and split it. This way I can merge them again. So I can say, okay, let's merge the really big array into another new array. And you probably will understand that you can do a lot of playing. You can have your own look in this palette. There are some ways. There's delete from array, so you can take away a part of the array, and you can do all kind of stuff with it. Okay, so far we have done work with arrays on integers, but of course you can put all kind of data types into an array, and I will show you some of that. So first I will clear away all this stuff to get a clean slate, and now we can have a look at this panel, and you will see that I have the constants here. Of course I have booleans, I have also strings, I have time constants, so I can work with time. I can do a lot of other things. I can work with references. I can do a lot of stuff, but let's do something with strings. So I was just working with integers, with arrays, and now I will do something with strings, which is in fact exactly the same. For example, I can put in string constant. So I will say, okay, hello, and I can also say world. And now there will be something happening which you don't expect, because now I can build an array of those 2 strings. I can even add an exclamation mark. And now I can create an indicator. And if you would now expect a long line, I will have to disappoint you, because what you will get is an array of strings. So again, you have the 3 single elements, and those single elements are inserted into an array. So now I have an array of 3 elements, and the first element is hello, the second one is world, and the other one is an exclamation mark. what you will see if I select the front panel, I get all the items, everything which has to do with the front panel. It's different, the pop-up menu, and I have just pinned some of the diagram pop-up menus. You can just pin them like this. Probably, maybe you saw me do it. And if I select the front panel, they are gone, and if I select the diagram, they are automatically back again. Back to arrays. Okay, I will come back to how you can manipulate strings to do this, to concatenate strings later. But again, back to arrays, you can do the same with arrays. It doesn't matter which data type they have. So I can create a constant, or let's do a control in this case. And then I can create an indicator. And now I've made a small program which is going to select a string from my array. So if I would now continuously run the application, if I select the first element from my array, which I've created here, I will get hello. In the second I will get world, and in the index number 2 I will get the exclamation mark. And now this is something which shows you that you can play with arrays, doesn't matter what's inside. So here I have the index, which is this index, and I can just select any item. Again, I can use the split and all other functions to do the things I would like with the array. And I could also do something with booleans. So for example, I could replace this one with a boolean, and the boolean is only true or false. You will now see a lot of broken wires because I cannot make an array which contains different types. But I can create, I can also replace this one with a boolean. I will do a false one, and I replace this one with a boolean as well. And now we will still see some broken lines because my indicator contains strings, and I can also replace those with boolean indicators, and then I will have the problem still here. And I will also replace the element within the array, or the element I show, with some boolean indicator. And I can run it again. And now you will see that I have selected index number 1. Index number 1 is the same as this index, and I can walk through the array to select elements. I can also use this item to browse through the array. The way I changed the data type inside is I can select something on the the edge of the array. In that case I will select the entire array. I can also select something which is just one element in the array. So I can select, I can replace the entire array with some kind of control. So instead of selecting an element within the array, I just selected the entire array, and I can replace the entire array with another element. Well, Control Z brings everything back to undo, but I can also select the element inside, and I can say, okay, let's make this a slider. So you can put in a slider in the arrays, so you can do all kind of neat stuff if you want to. You can also see if I select something new, it will automatically create an element of activate element. So now we've been to the first two items, static arrays and C, dynamics arrays, and now we are going to do some more fun stuff, and that's to place, to work with arrays and loops, and that's also the normal playing ground. If you are going to use arrays, typically you are going to use loops as well, and in this case I will be able to show you some nice features. I will first clean up the screens, and again we will do something with an array. In this case, let's make an array on the front panel. Why not? So I will select an empty array, control. I will start filling the array with, let's say, the sliders I just showed you. So now I will create an array which is completely filled with sliders. And I will also add a horizontal slider or vertical slider. Let's do it with a thermometer. And I will make this one a little bit bigger. And now I want to make something which is going to send all these values to this thermometer with some delay. So now I have my array constant here, of my array control, which is now empty, as you can see. And I will draw a for loop. You know the for loop. I can say, okay, let's run this for loop for 7 times. You know how that worked. But I can also connect my array to the loop. And now you will get a terminal which is indexing. If you would be looking really carefully, you can see some brackets inside, which are like the brackets you have in C. If I have an indexing terminal, I don't even need to connect my loop counter. The loop will now run just as many times as there are elements in the connected array. If you have connected more than one array, it will always use the array which has the least amount of elements. And if you connect arrays and the loop counter, it will use the least value of the size of the shortest array, or the shortest value, or if the value of the loop counter is smaller, it will use that one. What I will do is I will drag the thermometer into the loop, and I will connect my indexing terminal to the thermometer. If I would run this application right now, you will be a little bit bored, because it will do absolutely nothing, because the array is empty. So it will go to the array, you will see #0, which means that there are 0 elements, and it will stop because there's nothing to do. Okay, I will change the thermometer to scale to 10, and now I will fill my array with some information. So I can make some nice graph, and let's put them all just a little bit in this pattern. So now if I would run this application, it will go through this array of values. The first array element I set to roughly 9, the next one I set to roughly 8, and this way I now have an array filled with values. Again, I can do something here now. I can say create constant, and I will get an array which is a constant array, which is filled with the values I did set in this panel. So what you will see, what is actually in this array, is in fact a constant filled with, of an array, constant array filled with its values. If I would be writing it out in C, let's try to do something like that. I would be making a float array, and let's call this array, for example, values. And now I would be making something like values, and of course my values is a constant array. And now you see what I meant when I was talking about this is making constants filling them in is not something you really do a lot, because this is the way you typically make them. I will have to flip this one, and I will have now made an array something like this. And of course I can do a lot of things, but you get my point. This is how you can make the same array constant in C. Back to this one, Control E. So this is my array, which is filled with sliders. The sliders are floating points, and I will now run this program again. I have selected execution highlighting, so it will be quite slow, and then what we should be able to see is that the thermometer will start at the top, it will drop down and go back up again. I can put in a probe here to make it even more clear. A probe, and I can also put in a probe here if you like. And if I now, let me put this probe, this is the slide value. If I now run this application, you will see it starts at 10 and it drops down and it goes back up again. So in this case, I just took a for loop. I have enabled auto indexing, and in this way I will just step through all the elements in the array. So this is one way you can use a loop. You can connect inputs to the diagram, to the loop, and they are indexing. I can also disable the indexing, so if I want to use the array inside the loop, I can also do it with disabling the indexing, but for this case I will not do it. And this way, you can play with you can the loop will automatically index, and you can do some stuff. The other way around, if you want to do, I will I will play again with the thermometer. I will now swap everything around. I will now use the thermometer as my input, and I will build the array while I'm running. So I will swap these, and I will just say, okay, I will change this one to a control, and I will change this one to an indicator. And now you see nothing seems to have happened, but it did. If I now select my thermometer and I connect it, this is now a data source. If I connect it to the array, it will now generate values, and those values will be written to the array. To make it a little bit more clear, I will also add a single element. As an indicator, and I will put that single element inside the loop. As you can see, the diagram will not run it at this moment because I have connected a for loop, but I didn't select how many times the loop must run. So in this case I must connect some counter value, and let's say that we will run this application of the loop 10 times. Again, I switched on execution highlighting, and now I will start running the application, and what it does, it will for each iteration check the level of thermometer, which I've changed into a control, so I can in runtime change the value. It will show the value of the thermometer in element which I've drawn here, which is the same, and then it will create an array. For each time the loop is being run, it will add an element to the array. And once the loop has finished, the array is available and it will update the array output here. So this one is that one. I can now say let's again data operations reinitialize to default value, and this way I will clear the entire array. So now it's empty. Execution highlighting is on, so it will run quite slow, and now I can just do some stuff with the array. And you can see at the moment I'm changing, it will update the element down here. Now it has run 10 times, and after the 10 times I have my array filled with the values I've selected in the parameter where it was running. The same what I've done here with a for loop can also be done with a while loop. That's not really a difference between the while loop and a for loop. The only difference is that the while loop needs to have a stop condition and the for loop doesn't. I can even replace them quite easily. I can just say replace with while loop, and now instead of running after 10 elements, I can create a stop button like this, and now the program will keep running until I press the stop button. So let's do that. Instead of emptying each element myself, I can also select all items on the front panel, and I can say reinitialize selected values to default. Operate. I did have the stop element selected. I was expecting reinitialize values to default, and now all the items have been reset to the default values. So again, now if I run this VI, it will keep running until I press the stop button. So let's do it. And it starts with 0, and I can just change the slider value, and you will see the element running up here and going down whenever I like. And this will now run until I press the stop button. And now the array is filled with all the values. So this is how you can fill an array with all kind of stuff that you would like. One thing I did not explain is what if you would like to have the last element as well at the outside of the loop. If I connect a wire, this is different behavior from the while loop and the for loop, but it's not a for loop automatically indexes, a while loop doesn't. But here I can select enable indexing, and I can select disable indexing. If I enable indexing, that means that each iteration will add or will create an array, and the output will add an element in the to the array. And on the input, if I would say okay, create a constant, let's put the array here, and if I connect it to the input, again it's the while loop by default doesn't index, but here I can say automatic of enable indexing, and this time it will index each element in the array. So for the first element it will take the first iteration, it will take the first element, second, etc, etc. The same if I go to the output, if I create an indicator here, if indexing is off, that you can notice it because the box is just filled, it will only give the last element of the last iteration, and if it's indexing, it will give an array. So just to make it maybe a little bit more clear, is what I can do if I select disable indexing, So that means that the array is not indexed. You can also see it if I wire through, or if I draw a wire to it. This is a thin line, which indicates that it's just a single element. This is a thick line, which indicates that it's an array. And what I can do, if I would really want to do it, is I can select the index element. And in fact, if I select automatic indexing, enable indexing, this is what is happening. So now I have the element of choice. Yeah, this is more or less the most important things that are to be said about loops. Probably you will find some more clear examples of indexing and not indexing in some help or another video. So that was arrays and loops in auto indexing, and now we'll have some look at some basic functions, and let's start with scroll bars. So in the last example which I just finished, you could see I was getting quite a long array, and sometimes you don't want to scroll through the array manually. I can of course do it with keystrokes, and I can do I can enter a number to directly go to element 22 if it would be there. But if the array becomes really long, that's not really that useful. So what I can do is I can show a scroll bar. If my array is drawn vertically, I will get a vertical scroll bar. If it's horizontally, I will get a horizontal scroll bar. So now I can select the scroll bar and I can just scroll to the array. And this is really useful, for example, if I would make this one switched off. So now it will run at full speed. I can even create an indicator here to show you how many elements I'm putting into the array. And now if I would run this application, you will see it goes a little bit fast. So now I get a really big array. I can stretch this one, and you can see it just filled the array with something like 3 million points. So that's really stupid, of course. And here you can see that I was moving it. And if this would be an array which is filled with 3 million data points, and you would have to go through it step by step, it would be, of course, be very difficult. Let's make a nicer data set. I will again reinitialize values to default, so everything is empty. And this time I will try to make some nicer data in the array. Okay, and again I can scroll through the array, and you can see in this case it filled the array with 4 million points, and I can just scroll through the array using a scroll bar instead of making 4 million key clicks. I can also select somewhere more or less in the middle. So for example, if I go to some point where the data is relevant, I can skip. I can do 100,000 data points at once, so you can play with the arrays. Maybe for some reason you don't want to have these graphs anymore. I can again replace them by using numerics, and you see that it even retained the value. I can also select caps lock any element and change the size of the internal size. So now I have made a constant array which is quite long, and now I want to do some stuff. I have some UI information I just showed you, but maybe I also want to do some other things. I want to get the length, I want to search something, so let's have a look at that. Now of course this array is really long and it's not really that useful, so again I will clear everything away and I will start with a new example. I will take a for loop, and this is more or less the classical example, and let's make an array of 500 elements, By now you should be knowing what's going to happen. I am now making an array of 500 elements because I'm going to do a for loop for 500 times. I build an array as I go. I will switch on the vertical scroll bar, and if I run it once, you will see I will now get an array for 499 elements long. What if I would like to know the length of the array? I can just say okay, array size, and I get the array size, which will be 500 elements. What if I want to have the sum of the array? I can just go to my numeric calculations and I can say okay, just add all the elements in the array, and I can say okay, this is my sum. Ever wondered what the sum of all 500 first numbers is? It's this much. What if I want to have the average value? Of course I can divide the sum by the size, and I get an average value of 249.5. But I can also do something else. I can use the mean function, which is in the analysis tablet, mathematics, probability and statistics. I can just say okay, what is my let's measures of spread. No, I will get the median value, which is really nice to have. So I can just select all kind of stuff and I can get the median value, which is the value which is most common, and of course that's very strange. If you don't have a value, then it will take the average. No, it will take the average between the two most common values, which is of course our median is sorted, and then take the middle value. Yeah, so that's the 249.5. And let's do some other stuff. I can, instead of taking the integer or the count value, I can also take a random number. And now if I select this one, the random number is between 0 and 1. And now these are all based on integers. If I now, and this output is a float. If I connect this one to the float, it will color all the wires orange, which means they are floats. So blue lines are integers and the orange lines are floats. And now you see this one, this array still is an integer. If I would run it, all the values will be 1 or 0, and I just want to show floats as well. Again, I can run it and I get a different set, and of course each time I run it I get some other value because this is a random number. And what I can do, let's play a little bit. If I want to sort all the elements in the array, I can just say insert sort array, and if I run it now, I will get all the values of my random generator nicely sorted from 0 to 1. If I want to have them sorted in the opposite order, I can say insert array and I can reverse the order, and I get all from 1 to 0. So this was really quickly how you can do a lot of playing with arrays and some stuff. So this was, I forgot one. I want to show maybe the search and the min-max value. They're roughly the same. Let's do them. The min-max, always nice to have. Let me just pick this one. There's the min-max value. I can connect an array and I can say okay, create constant, create indicator. This is the maximum value in the array, and I can also create an indicator which is the minimum value in the array. And now you will see the minimum value is, the maximum value is nearly 1 and the minimum value is nearly 0, which you would expect of course. I even get an index to show me where the minimum value is or the maximum value. So I can create an index, I can create an indicator here, and it will show me the minimum index. And if I run it now, it will say, okay, at 474, you have your minimum value. Okay, you see this is, and my minimum value is 006, and it should be at index. That's I put in the value where I'm going to calculate the minimum and the maximum value is not the same as the array I've displayed here. So I will, because I sorted that array, this is the sorted version of the array, and now I have the sorting removed, and now it says, okay, this time your minimum index is at 327, and I will see, okay, this is really nearly 0, because it shows me 0 as well. The search function I will not show you, but you can imagine yourself, because these are floats and it's difficult to search for floats. But this is the search function. You can have a one-day array in. You can say, okay, this is the element I want to look for. This is the index where you can start searching. And this is the index of the element if it's found one, or -1 if it isn't found one. Nice feature, I can say show context help. And if I have the context help, whenever I move over an element, it will show you some help function, for example the mean, and it will also allow you to select detailed help, and then it will open the complete help window with a lot of extra information, whatever you need to know. This is a good way to get some information. You can even find examples and do all kind of stuff. Okay, one thing I did not put in this agenda, but I will show you as well, are multi-dimensional arrays. All the things I showed you at this moment are one-dimensional arrays, but you can just as easily make multi-dimensional arrays, and I will show you quickly how I can do that. So suppose, let's get rid of this. What is a multi-dimensional array? I just showed you an array which is one direction, so I can add a number and I can stretch out in this direction. Sometimes you are going to use a multiple dimensional array. Let's do something in C, so I can make an array X direction and an array in Y direction. This is a multi-dimensional array. So if you want to make an array like this, you can do it in Labview as well. Just simply drag your indexes, and now you will see that it also changes this item of this symbol. I can just now make it a two-dimensional array. If I would now create some kind of, if I would connect a wire to it, if I would index it, you will also see that the wire now has changed to a double wire. If I change it back to a one-dimensional array, you see it is a single thick wire. If I change it to a two-day array, it becomes a bigger wire. And if the more dimensions I add until a certain moment, the thicker the line will become. So you can see that as spacing. One thing I can do as well, if I add for loop or loop within the loop, if I am indexing, it will index at the first dimension. If I now go to the second loop, you will see that it has changed. This case I have a 2D array, which I am indexing once. I will get a 1D array, and then I will get my element. If I now add more dimensions, you will see this is a 3D array, This is a 2D array, a 1D array. This is my element. And I can just add and remove dimensions as I like. Very common is a 2D array. Again, if I am going to select a sub element of my array, or if I'm going to index, I can index it either in row or in column. In that case, I will get another array. I will put it to another loop because then you get the wire. If I select only one item, it will return a 1D array. If I index both items, it will select one element. So this is multidimensional arrays, which are basically the same as one-dimensional arrays, only in more dimensions. Okay, and now let's go to the last part, and that's the bad implementations. Any programming language is something which you can make a really big mess. If you are going to make a mess in C, you get into a lot of trouble. If you are going to make a mess in Labview, Labview will guard you, will prevent you making a too big mess. You will get a poor performance, and especially if you are new in programming in Labview and you don't know exactly how performance is influenced, you might get to writing some code which is really low performance. But on the other hand, if you do something in C, you will get really big problems. Well, what is the problem why I say C is dangerous? Well, I've got the danger code right here. Of course, every C programmer immediately knows what's going wrong in this case. I have an array, I've declared the array, and I have some function, and I have an array of 10 elements, and I select the 10th element, and I am going to add the value, set the value 12. I'm not even working with pointers, because if I'm going to work with pointers, I can make an even bigger mess, and this is already a huge mess. What I've done, I've created an array of 10 elements, and I am now writing to the element number 10, which is in fact the 11th element in the array. But as the array only contains 10 elements, it means that this 12 is written somewhere in memory. And if you are lucky, it is memory which is not being used, but typically it is. So at this moment what I'm doing, I've made some completely legal C code. And of course you can say, okay, the compiler can catch this mistake. But if I would make this one a variable, then it will be impossible for the compiler to catch this. So if I would do something here with I is 68, and then I would call some function, I am now writing somewhere randomly in my memory. I can corrupt my own internal data, and it's even worse because if the array is long enough or the value is strange enough, I could even be writing somewhere in my code. And this will cause crashes and bugs and all kind of things, and these are really hard to tackle. If I would try to do the same in Labview, let's get rid of all of this. So again, I will create an array like this from 10 elements. And of course I have my index element. So this is more or less the same code. I will put in and create an indicator or control so I can show you what's happening, and I can create an indicator here. And I will also, for clarity, create an indicator of the array I'm going to make. So now if I run it once, you will see I will get the array 10 elements which are filled with 0 to 9, and I can just run it continuously, and you can see if I select an index I can go up to 9. I just by accident clicked too far already, but if I go too far it will not do harm. It will just stick. Okay, it says okay, you're outside the limit, then I will revert to the first value in the array. Same if I go back, it will revert to the first element in the array. Of course this example is not exactly the same because I didn't change anything in the array. Well, I can do that as well. I can say replace array subset, and in this case I can replace an array element. I will also connect it to the index, and I will create fill it with a constant, let's say 99, and I will create a copy of the array. So now I'm going to write 99 to a position in the array. So let's start at element 7. I will run constantly, and now you will see me jumping with the 99. And now if I go further than 12, it will not write anything, but it will also not write it somewhere in memory. So it will just not change anything. Same if I go back to negative values, it will not change the array, but it will also not write the 99 to some location in my memory. So it will save it, because in runtime Labview knows what I explained before. Labview knows the length of the array at all times. All arrays are dynamic by nature, so it will protect you from making these kinds of mistakes. And that's why Labview is a lot safer to program with arrays than standard C is. Okay, that's about the danger with C. But if C becomes dangerous, then you still can get huge performance issues in Labview, and I will try to explain them right now. So let's make a first program that crashes. That's not that difficult. I will make a while loop, and I will create just something like this. I will run the while loop, and I will enable indexing, and I will now create a constant. So now the while loop will put in all the elements in an array, and I will create an indicator here. I will even create an indicator for my loop counter. So this is something you can do really badly, really quickly. If I would now run this program, I will get a crash, because I am now running the while loop forever. That means that it will add an element to the array forever, and at a certain moment my array will become really, really, really long. I can show you another nice feature of Labview. Not this one, this is not that complicated, but I can say display format, and this is not going to happen that quickly. It's going to need some lot of memory, and I can say okay, show me the formatting in SI notation. So that means that it will put in megas when I start running it. So if I first run it shortly, I will run it and immediately abort it. You can see now it's added 4M elements, and as I stopped the program before it crashed, it didn't fill the array because I stopped it somewhere in the loop. But now if I don't stop it and if I keep it running, what will happen is that it will create an array dynamically which is bigger than my memory, and it will do that quite fast. And it's now 8 megabyte memory, and I don't know why it's Probably I was expecting it to run out of memory, but you can see already I've created 975 megabyte of memory. You can see my CPU has gone completely mad. If I look at the one who's going mad, it's still not even Labview, but it's the system idle process and the Bandicam. So that's the application I'm using to run everything. But let's have a look at the memory. If I now run this program, probably you will see memory just exploding. There is some smart intelligence. I don't know exactly what's happening, but it looks almost like the screen capture program is conflicting. You can see a lot of energy being used. I will pause the video and make a jump. Well, anyhow, you can see that it's now it starts running faster. Okay, this is what was supposed to happen. Yeah, and the video is also, the recording is also running. So normally it would have happened quicker, but it's due to the screen capture software, which is making a little bit of mess. But here I get my crash, and you can see everything is hanging, and it shows a dialog outside the screen, and you can see I get an error message, not enough memory to complete this operation. And you can also see that it's trying to create 77 million data points, and at a certain moment it cannot, because if you are going to use arrays, it needs to have a continuous piece of memory, and at a certain moment it cannot capture that memory and it will just stop. And I get an error message that says Labview full, and it will gently stop my application and everything is back to normal again. So what I just did is I made a stupid program which is allocating a lot of memory. Performance completely crashed, and yeah, still things were more or less savable. So this is one way you can make a problem. Another major performance issue is if you are going to make a function, which I explained in the previous video. If I would make a sub-VI of this one, create a sub-VI, I cannot make a sub-VI of nothing. Let me insert, for example, what I can do is I can just add one to, in this case it's the same as the what I showed before, add array elements. One really cool feature I didn't even show you is that you can insert all kinds of numeric values in an array as well as in the normal numbers. So in this case it will add one for each and every element in the array. Now I can select this part and I can say create sub-VI. Something. It cannot create a sub-VI yet. I know the reason why, and in fact of course it's too stupid to make a sub-VI of something like that. Concatenate inputs so that it will remain a 1D array, and I will also concatenate inputs here. What you see, if you build an array, you will get if you add two 1D arrays, you will get a 2D array. And if you say concatenate inputs, it will stack the arrays after each other. And now I should be able to create. Okay, sorry, I'm a little bit. It's getting late. I should make the create sub VI from the menu instead of the pull-up menu. But now I can create a sub VI, and now I've made the sub VI, which is containing the code which I just captured. And one of the performance issues you can get is what I've just made a very good example of it. Labview does everything by data copies. So now here I make an array. Let's say, for example, I will replace this with a for loop, and I will run it for 1,000 times. What Labview now has done is it has created an array here which is 100 elements long. Then it calls this sub VI, and for calling the sub VI it will make a copy of the 100 element long array and put it here. Then in this case I will add 1 to my array, which creates a new array. So I have a new array of 100 elements. Here I will build a new array which is 2 times the original array, which is another array of 200 elements. Then I will add those arrays to each other, and I will get a new array of, in this case, 300 elements, and this array will be sent to my calling VI, which will make a copy again. So now I have a copy 1, 2, 3, 4, 5, 6 copies of my array. It's even worse, because if I have this VI open, it will make a copy as well for my indicators. So it will add another 2 copies. As I have an indicator here, it will also create a copy for this indicator. So because Labview does everything by value, instead of having one array, I now have 7 or 8 copies of the array in memory. And this is something which typically is not really a problem, except if you're working with really long arrays, you will get into some performance issues. There are some ways to work around it, but that's one of the things you have to keep in mind if you are working with really big data sets. And if you are using arrays, then you really must take care that you don't mess up and that you are taking good actions to control your memory. And I will just look up some information which you can read, but it's more for advanced users. Looking this information up, it's not that complicated. Just Google memory management Labview or something like that, and you will get a lot of information from Labview itself. And I think this one is the most important one. It is a Labview performance and memory management, and it will, if you start reading here, you will get a lot of information of how Labview uses memory. So just Google it and you will get a lot of information. Lava.org, that's Dutch, I believe. I'm trying to see if I can get the correct one. I will pause the video again. Okay, back again after some search. I was not really able to find the correct page I was looking for. But at least if you are Googling VI memory usage, you will get VI memory use on the Labview help. And that's really a great starting point. It will show you really a lot of information on what is happening with memory and how you can optimize it. But I will get back later to some examples of how you can do it. just for you to know that you have to take care if you're using big arrays, and there are ways to work with it without too much hassle. Okay, so that's more or less everything for this video, and I hope you've enjoyed it, and hopefully see you back at another one.